Hi everyone. In today's video, we are going to discuss about the NR slot configuration types with the one highlighted in blue here, where we have three types for NR TDD, static TDD, and semi-static TDD and dynamic TDD. We'll explain the differences between all of them, and also we'll go through some of them with log files just to explain practically how you can check the current configuration for any network through using log files. All the remaining parts here for the main consideration, back assessment, and other double scheme, this was already previously explained in another videos. You can just refer to the link in the top right here in case you would like to check this kind of details. So let's move forward to see what we have today. So actually, this is a 5G part. The 5G part actually, again, it's having a similar figure compared to 4G, which being that but this time it will be considering in slots. As you know, the scheduling in the 4G and 5G is being based on slot, not subframe. So here, for example, if you're using SC subcarrier spacing 30 kilohertz, this means you will have 20 slots per frame. So each slot can be even downlink or uplink based on the configuration which you have it, and it can be even being something called flexible. And this one within flexible it can be having a mixed symbols as shown here, for example. So the main difference is about between the 4G and 5G that the 4G can use the exact same concept as the 4G, which is being static. You can configure static resources, for example, 8 for downlink, 2 for uplink, for example, like that. This can be for the static, and it cannot be changed if you give it static from the beginning. Or it can now the NR introduced to new concept which is called semi-static allocation or dynamic allocation. The semi-static allocation, it can change some of the flexible if you kept it during the static allocation in the beginning, you kept some of the slots as flexible. This can be later on being dynamically changed by the network, but only for one time. For example, to change the sum of this flexible symbols even to be completely downlink or mix it and so on. And we'll be discussing this part as well to show how it's being working. Then the last part, it can be dynamic. The unit B can change this one from, for example, initially it can assign this kind of configuration. Then again, for the same slot, after some time, it can change it, for example, to completely downlink, all downlink, or partially downlink and uplink and so on. This is the dynamic allocation. But again, dynamic allocation can cause something called cross-link interference, and we'll explain this part as well. So now let's move to the static allocation and move through one by one to see the details about it. This is the first type of the slot format configuration for the TDD. Here, it's, as I mentioned to you, it's exactly the same concept as 4G, where you give a fixed configuration. You can even assign it for all the slots which you have it, and then within these slots you can have a special slot, and again you can give it some particular samples. So actually, if you look into this table on the left, this is just the parameters which are being mainly used whenever you're going to allocate the resources. But usually the operator will give you directly, or the vendors will give you directly. Not you will not make, for example, here you have the transmission periodicity or downlink slots, downlink symbols. Each one you are giving a fixed configuration for each and every single parameter. No, it's not like that. Usually the operator will give you the final figure. For example, in this example, I'm giving that this vendor is configuring 7 for downlink, 1 for the special slot, and 2 for the uplink. So this is how it looks like. It's called, like, for example, TDD pattern. And as you can see, the parameter is called common, and will be static all the time. So for example, in this one, as you can see, if you go through the parameters which you have it here in 5G, we have something called two patterns. For example, pattern 1, if you can either having one pattern or you can have two patterns. So let me explain what I mean by this. First of all, if you have, let's assume that you have one pattern, which is the example which you have it here, and this is the parameters between this part. So what it means by these parameters, first one is called transmission periodicity. This one actually identify what kind of period you're going to have for the configuration you are going to configure. Let's assume that you have here configuring here, for example, 7 downlink slots. So this is, for example, will be repeated every transmission periodicity. For example, if you give it 5 milliseconds, this means this 7 downlink slots will be repeated every 5 milliseconds. I will explain it now with examples. But the downlink slots, whenever you have, for example, 7, it will be configured at the start of the duration. For example, if you have, assume now you have 7 slots here as this example. So this means you will have 7 slots at the start of the duration here. Then you will have here the number of downlink symbols. Let's assume that you give it, as we mentioned here as well, 6. This means that the slot which is follow those 7 slots will having 7 symbols of downlink. So for example, this one, you have 7, then the number of symbols, assuming now it's being configured as 6. So this particular slot, which is following the downlink slots, will having a 6 symbols as showing here. So this one. And now going to the uplink here, for example, you are giving as mentioned here 2, for example. So this one is starting from the end. So you need to go to the end of the transmission periodicity, for example, at the end of 5 milliseconds, and start counting 2. So it will be here as 2 to uplink. And again, you will have this one, which is the uplink symbols as well. As you can see, as defined here, uplink symbols define the number of uplink slots, symbols, sorry, defines the number of uplink symbols within the slot precedes the slot uplink slots. For example, this one precedes the uplink slots, right? This one, which is F. So now, again, it will be configured at the end of this symbols, as mentioned also here. So, for example, you are giving here as 4, so you will have 4, and all the remaining will be considered as a guard band for the remaining here. And in case, for example, here you have only assume, for example, you have 5 slots. So this means you will have 2 flexible here. It will be kept flexible. There will be no change. Flexible here. This is in case you are giving this kind of configuration. So actually, the message on the right here, this is how you can verify from the UEDT logs. For example, assume that you have a benchmarking between operators and you would like to check what kind of configuration being used by the other operators, or even to verify it in your network if you did any change. So during the HTTP addition, this configuration will be delivered under our serial configuration message. You need to search for something called TDD uplink downlink configuration common, which is exactly the same as this one, and that you'll find that it's exactly finding or giving the exact same parameters we're showing here. The example I'm going here, it's used to have one pattern. So this means if you have only one pattern, the pattern will be repeated every UST, or for example, every open 5 millisecond, depend on the settings which you have in the network now. So for the example here, I'm showing it as 5 millisecond, and here is the parameters. You can see here MS5, this means 5 millisecond, number of downlink slots 7, so this means 7 downlink slots, and you have number of symbols within the slots which is follow those 7 slots, which means slot number 8, which we consider as S special slot, will having a 6 symbol within this F or S special slot or flexible slot. Then the block slots will be 2, as we mentioned. Here is showing 2, so these 2 slots, and you will have 4 symbols. So the final configuration will be like that. You will have 7 for the slots, and we consider this one in the written or whenever you write it as 7 here, and this one will be S, which is special slot, and then you will have 2 for the uplink, which is called A2. Usually this configuration called as A2. And the special slot or special button or flexible button, it will be 6, right, for downlink, which is 1, 6 for uplink, and the remaining, which is 4, because you have 14 symbols, it will be for the guard band. Okay, now let me explain what it means by pattern 1 and pattern 2. So when I told you that, for example, if only one pattern is being included within this message, this means the pattern repeats periodically based upon the configured transmission periodicity. This is even if it's only one pattern. Assume now you receive one pattern here with particular configuration, then you have pattern 2 as well in the same message, okay, with another configuration. So what will happen in this case? If 2 patterns are included within the message, so that's then the second pattern will follow the first pattern. For example, the first pattern will come first, then the second one will follow the first one. Okay, this is the first part we need to do. And the pair of patterns repeat with a period of equal to the period will repeat for a period equal to the summation of this one, downlink transmission periodicity, and the downlink transmission periodicity of pattern 2. And one important point as well, or note, 3GPP specifies that the sum of the 2 patterns for this one, for the periods of these 2 patterns, must divide into 20 milliseconds. For example, assume that you configured as a first pattern 2 milliseconds, and this one 2 milliseconds. So this can be divided by 20 milliseconds. But if you divided the first one as 1 millisecond, for example, and the second as 2, this cannot be divided by 20 milliseconds, so this is not allowed. 3GPP will specify that this will be allowed. It must be divided by 20 milliseconds. So this is how, if in case you found different patterns in the network, this is how you can do it, as I just explained. So now let's go to the next part for about the semi-static allocation, then the dynamic allocation. Just one last part before getting to the semi-static allocation. This message also, if you are working with 5G standalone, you find it in SIB1, System Information Block Type 1. Just to let you know as well for the standalone, for example, as mentioned in this particular comment here. So now let's move to the next one. So now this is about the semi-slot assignment or semi-slot configuration. The first one was about the static. Actually, the very, very important comment which I would like to tell you, for example, assume that from the static one, which is, if you remember, the parameter called TDD uplink downlink configuration command. Assume this was your configuration. It left this kind of flexible slots here, and this green one and move one. This is the special slots which are having a specific symbols or symbols for downlink and so on. So assume this was my configuration from the common one, which is having a static allocation. So whenever the semi-static is going to the figure, it can change within only the one which is remained as flexible and the one which is being flexible also or being used as a special slot for symbols. But whatever being assigned during the slot, for example, the static allocation which is being downlink or uplink is explicitly mentioned as downlink and uplink, this is cannot be changed at all. This is will be kept all the time like that. So this means that this kind of semi-static will be changing within those particular flexible slots to, for example, a particular configuration or fixed configuration which we need to configure in the network. For example, as you can see here, this is it's called first of all called TD uplink downlink configuration dedicated, and this is usually also delivered by the RSC configuration message whenever the network see the needs for a particular users or cell to configure or change the configuration for those flexible slots based on the demand on the network or so whatever, and based on the configuration we're giving as well, it will start sending RSC configuration to the user to send them the new configuration about this flexible slots. So as you can see, for example, here, this is called a slot specific configuration to add to mod list. You have a slot index. So this is explaining that, for example, the number of slots which we require to change. Here it's showing up to 320 because we can have 320 slots whenever you're speaking about the higher SCS, which is 120, 140, and so on. But currently it's being fixed to 80 only, 80 slots only, which is up to 60 kilohertz as I remember, or 120. So this is giving you the slot index, for example, which slot needs to be configured. So for example, let's assume it's highlighted this particular slot, let's say slot 8, for example. And now within the slot 8, it will tell you what kind of symbols you're going to have. For example, all will be downlink or all will be uplink, or how many for downlink, how many for uplink. And it's giving like that. At the end, it will change the remaining. For example, let's assume it's giving 6 for downlink and 4 for uplink, so the remaining 4 will be considered as guard band. So this is just to configure this particular flexible slot. So in this case, it can change. As this example, for example, here it's assumed that, as I mentioned to you, that the first one here for this green one highlighted here, this actually was being configured partially as number of symbols by the during the slot static allocation. So it's considered like, for example, this 6 as downlink and the remaining was flexible. So whenever this static configuration came, it changes this one to complete downlink. So now it will change this one to be all downlink. So this one will be all downlink. And this flexible one, it will be also changed to all downlink. And for this, the third one, which is flexible one, here it's considered as to keep only 6 for downlink. As I told you, whenever the number of downlink symbols coming as 6, for example, it will follow for the last slot which is being indicated as downlink. So this one now, it will be coming here as green as well, which is having partial number of symbols to downlink. For example, here, 6 downlink and the remaining for flexible. And this one, it didn't touch, didn't change it. The configuration, whenever the GNB decided. So this one will kept as flexible. It will be reserved resources. There will be no transmission or the user will not be receiving or transmitting anything about that part. It can be used for any other purposes. For example, whenever you have dynamic spectrum sharing, so this can be reserved for the transmission for the 4G side within this particular area or frame. This is as an example. Now for the other part here in the last three, or the last four, the GNB also decided to change. The first one we should move from the right to left here. So for example, the first one here, it was partially also configured with uplink and the remaining was flexible. GNB decided to change it all to be uplink, as you can see here. This one flexible also changed to all uplink. This one flexible changed also uplink. This one changed to partially, and this partially will be also a same configuration. For example, 6 for uplink and the remaining will kept as flexible. Still, you can give downlink and uplink within this part. It's up to you. This can be done as well. It can be, but it's already configured here, so it cannot be in the same because already configured in the beginning for the downlink. So actually, what will happen? This is now was a common one, which is coming in the static figure, which we explained in the previous slide. And now this is the dedicated. So it will combine both of them, and this will be the resulting of the semi-static pattern. So this will be the resulting. This is what the user will see. Will be this is all downlink, and this will be partially for downlink, and this will be flexible. Then we'll have this one, which having no transmission at all. Then we'll have this partially also for uplink, and the remaining will be flexible. then all the remaining will be for uplink. So this is how it's being changed. It makes it both of them and give you this kind of results. And actually, this one I didn't see it yet being used by any of the network which I work it for. So please, if you see this example as a practical, you can also drop a comment and add your experience in the comments. So now let's move to the dynamic part as well. So now for the dynamic part, as you can see, it's actually working on the remaining flexible slots, which is being left over from even the semi-static or from the static configuration, whatever flexible slots. But the main advantage of that part that it can dynamically change the slots. For example, it can change this a slot. For example, let's say it's having 14 samples. Sometimes it can make it the all downlink or all uplink or partial downlink and uplink. This can be dynamically changed based on the load or many other factors in the network or the services which is being introduced. For example, if you have services require high latency, so it might give you more uplink symbols within the downlink slots, as an example. And if you have heavy downlink, so it can give you this one as all downlink, or heavy uplink can be all uplink as well. So this flexible can be dynamically changed as well. As you can see here from that part, first of all, this is being done or delivered through the BDCH, like something called DCI format 2. This will be the remaining symbols as mentioned here can be dynamically reconfigured using DCI format 2. And first of all, as you can see in this parameter, it's called slot format indicator, something called first SFI RNTI. So each user will be allocated with this SFI RNTI before receiving this kind of DCI information. Once you receive the DCI information, this DCI information to format 2.0 provide this is U group comment signaling. So it will be sent for a group of users, which is allocated with the same exact SFR RNTI. But each one of those users might having a different slot format indicator, by the way. For example, here in this particular parameter, which is called position in DCI, which is also being delivered, or the settings will be delivered in the messages within the DCI format 2.0. This one can, for example, having a specific value, which is specify the location of relevant slot format indicator. For example, and this one will take you, once you have this SFI format being identified, it will take you into 3GPP. It will be like a pointer towards a 3GPP table to tell you which slot is going to use which symbols. For example, it will indicate that this particular slot will be used this SFI slot format indicator 0, which means that this particular slot will use all the symbols will be used as downlink. This can be, as you can see, 40 symbols. And we have a total of 56 combination, and also we have combination of 250 and 256 reserved. This is like not being used. So currently the 3GPP supporting up to 56 combination from 0 to 56. So this kind of flexible format can be using on any of these combination, whatever based on whatever the GNLP decide based on different factors like such as the services, load, and so on. So these kind of flexible slots can having a dynamically change and within the symbols which are being occupied by this kind of of flexible slots. And again, the dynamic can only change on the remain flexible or partially configured as downlink and uplink, but it cannot touch whatever being identified as downlink and uplink. So it will be only working in this area. So now let me give you a quick example about this part to show you like how it can be showing, and also I'll be showing the complete 3GPP table just to give you more details about it. So this is also whenever you need to look into it, this is the table number, and this is the 3GPP version whenever you need it. So this is a complete 3GPP table, as you can see here. It's up from 0 to 55 combination. For example, the first one 0 format SFI format 0, it's having all the symbols as downlink. Format 1 having all the symbols as uplink, and it will be different from one to another. And this 56 to 54 is being reserved, so not being used currently. So I'm giving you now an example. Assume now that GNLP decided to change this kind of format through DCI 2.0 for users, for a particular user. For example, this kind of slot, it requires, for example, to use this kind of slot format. Let's assume SFI 28, for example. SFI 28, for example, let's assume that GNLP now saying that this particular user is demanding a very heavy downlink traffic. So now it will require to give him more downlink symbols, as you can see here. So, for example, it's using this kind of slot SFI 28. It will be delivering this to the users, pointing towards this particular combination, which will tell him now you will have 12 symbols for downlink, as you can see here, 12 symbols, then one flexible and one for uplink. This is in case of SFI 28 being addressed. Assume now another user is having a very heavy uplink. So in this case, this F will be changed to, for example, combination, which is slot format 34, which is this one, which is first one downlink, then flexible, and all the remaining is being uplink. So this can give higher also throughput. Assume now you have a slot aggregation. For example, assume that you have from mobile broadband heavy downlink transmission, and you require even more slots with more downlink slots. So even this can be done through the DCI format. So for example, it can combine this SFI 0, which is having all downlink, with for example SFI 28. So it will tell him, for example, these two flexible symbols with flexible slots will be using will be their slot format. The first one will be completely downlink, and the first one will be 12 for downlink and one flexible and one for uplink. And again, you might see this in many different documents and so on. As I know, it's not currently being used yet. This can be used in the future to be having more advanced allocation for the resources. But this is kind of having some risk, and it required to use in the particular scenarios where is the cross-link interference come to the figure. And for all the related rest is related to dynamic slot assignment. This will be explained in different video. Also, we have it already in one of our videos, which already shared in the beginning of this video. Thank you for watching, and please press like and share it with your friends. Thank you very much, and see you next video.